Dear viewers, today I am going to describe the two subtopics of chapter Electrostatics, which are electric potential and the potential field as potential gradient. We are going to describe the topic with the help of this simple example. In this example, we have two oppositely charged plates, positively charged plate and a negatively charged plate. And between the plate, a positive charge Q is placed. If we want to move the charge from positive charge from this negative plate to the positive plate, for example, this is point A and this is point B, and if we want to move the charge from point A to point B, then we will apply an external force in the upward direction. So there are two forces acting on the charge, the external force which is in the upward direction and the electrostatic force which is in the downward direction. The external force must be equal to the electrostatic force, and if the external force must be equal to the electrostatic force, then the charge moves with the uniform velocity. And if we move the charge from point A to point B, since the charge is moving against the field, so its potential energy increases and it becomes maximum at point B, where we know that at point B it has high potential and at point A has low potential. Now the increase in potential energy is UA minus UB. Since, as I have told you, at point B it has maximum potential energy and at point B A it has lowest potential energy. So when the charge is moved from point A to point B, then increase in potential energy is UA minus UB, and increase in potential energy is equal to the work done. In other words, I can say that if the charge is moved from point A to point B, then work done is stored in the charge, and that work done is stored is equal to the potential energy. Therefore, UA minus UB is equal to WAB. And the increase in the potential is delta V. Potential is represented by V. Change in potential, increase in potential means delta V is equal to VB minus VA. It means increase in potential, which is equal to work done per unit charge. And that work is equal to potential energy. So we can write it as potential energy per unit charge. If we bring the charge from infinity to that point, if we bring the charge from infinity means where there is no field, to point B, then the potential at infinity, which is VA, which is equal to 0. So the above equation will become VB minus 0 is equal to WB upon Q naught. Or we can write it as VB is equal to WB upon Q naught, or V means electric potential is equal to W upon Q naught. So the definition of the electric potential is work done in bringing a unit positive charge from infinity to that point. So our second subtopic is electric field as a potential gradient. In this topic, we are going to discuss the relationship between the electric potential and the electric field intensity. Now, as we have read this equation that the change in potential VB minus VA is equal to work done upon the magnitude of the charge. We know that work done is equal to force multiplied by distance. And the force, that force F is equal to the applied force, which is equal to the electrostatic force. Since the charge is moved with a uniform velocity, therefore the applied force is equal to the electrostatic force, but in opposite direction. Since the applied force is in the opposite direction, so applied force is equal to minus Q naught E. Since the applied force is opposite direction to the electrostatic force, the electrostatic force is acting in the downward direction, while the applied force is acting in the opposite direction, but have same magnitude. So applied force is equal to the electrostatic force, which is Q naught E. Since it is in opposite direction, so we will write it as F is equal to minus Q naught E. So the work done is equal to force multiplied by distance, and we know that applied force is equal to minus Q naught E multiplied by distance. Now put the values in the above equation. So the above equation becomes VB minus VA, which is equal to minus Q naught ED upon Q naught. These two Q naught will be cancelled. So here the potential difference VB minus VA, which is equal to minus ED. E for intensity, D means distance between the plates. Now multiply both sides by minus 1. So it will become this minus minus plus ED is equal to minus VB minus VA, or we can write it as minus delta V. Delta V means increase in potential or change in potential. Now E is equal to, intensity is equal to minus delta V upon D. Okay. Now we can write D as R if the distance between the two plates is very small. So we will take the distance between two plates is delta R. So electric field intensity is equal to minus delta V upon delta R. Potential difference, or we can write it as electric field intensity is equal to minus potential difference upon the distance between the plates. So here in this topic we have studied the relationship between the electric field intensity and the potential difference. Thank you very much. Allah Hafiz.